I'm Anil Kumar. Welcome to my series on functions. The question before you is from one of our subscribers. It is an amazing question, and let me thank my subscribers for sharing brilliant questions. I'll request Mr. Dylan, who has shared this question, to also share the complete test paper, as this happens to be one of his test questions. We'll see how to solve such a question in this particular video. Using mapping rules, describe how the graph of f of x equals to minus 0.6 divided by 2x minus 2 plus 3 can be transformed into the graph of g of x, which is equal to 1 over 3x plus 9 minus 11. Indeed, a very difficult question. So let us try to understand the method. We are given two functions, f of x as equal to minus 0.6 divided by 2x minus 2 plus 3. Now, minus 0.5, think like this, can be written as 6 over 10, which is 3 over 5, right? So you could actually write this as minus 3 over 5. Now in the denominator, you can take 2 common, you should, so that you can describe the transformations properly. So that is how you could write your function f of x. Perfect. Now g of x. G of x is given to us as 1 over 3x plus 9 minus 11. So here we can write 3 common in the denominator, x plus 3 minus 11. Clear? That is the first step. Now we need to see how are they related, or how do f of x get transformed to g of x. As you can see, both of them are transformed from the parent function. Let's call that parent function as p of x equal to 1 over x. So the transformation is basically from this function. Is that clear to you? So to relate them, it is a good idea to see how they are related with the parent function. So that is kind of critical to understand. Once we do this relation, we have something in common, then we could actually write the mapping diagram. Otherwise, it could be very tricky. So I hope you understand this part, right? So let's look into this flow. If the parent function is the reciprocal function 1 over x, how do we get f of x? Well, and how do the points get transformed? Now here clearly we see that horizontally it has been compressed by a factor of half, so the coordinates in this case could be written as half of x, and then 1 unit it has been translated right. So that means increased by 1. So that is how the x values have changed as compared to the parent function. Y values have been multiplied by minus 3 over 5 and then moved 3 units up. So with reference to the parent function, that becomes the transformation. Clear? On the other hand, with reference to the parent function, the transformation is the x values horizontally compressed by a factor of 3 and then moved 3 units left, that is minus 3. The y values, y as such, nothing happens vertically, minus 11. So that is the transformation of g of x from the parent function 1 over x, right? So one step. The next step is to relate these two. Is that clear? So we'll start with the multiplication part first. So let me begin with these two factors. So what we see here is that the horizontal compression, here it is half x, here it is 1 by 3x. How do we get this result? Well, clearly, I have to multiply by 2 over 3 to get this result, right? So So the transformation, if I am saying that my coordinate points, let me write here on the side the coordinate points, and then we'll actually work out in details. So if I am saying that on this side my coordinate point is x and y, this is on f of x, right? So this is on f of x. Then on g, what has happened here is, as far as this is concerned, horizontally I have to multiply by 2/3 to get the result. Is that clear to you? Right? So this point here should be 2/3 times x. Is it comparing these two values, right? Now let's get into the vertical transformation. Now in the case of vertical transformation, okay, let me write a comma here. In the case of vertical transformation, what is happening here is that y value is -3/5, and here it is just y. That means we have to multiply this by -5/3, right? So what we get here is -5/3 of the y values. Is that clear to you? So as far as the compressions and stretches and compressions are related to horizontal and vertical are concerned, you get your points. Now let's talk about translations, right? Okay, so let's talk about translation, horizontal translation first. We have already multiplied this by 2/3, correct? So what I'm trying to say here is that we have 2/3 times half of x plus 1. So if you open this, you really get 1/3x plus 2/3. Now this has to be compared with 1/3x minus 3. Do you see that? So let me write here. This we are comparing with 1/3x minus 3. From here I'm writing this. Is that clear to you? So these are the two comparisons which we are making. So horizontally, what is the difference? Well, it is -3 minus 2/3, right? So what we get here is, relating these two, we get -3 minus 2/3 as the result, which is equal to -9 minus 2/3, or I can write -11/3. So this is -11/3. So do you understand how we got the translation part? So we equated the stretches same and then compared the translations, and we got our result. Is that clear to you? Perfect. Now we are going to do exactly similar thing for the vertical. So in the vertical part, you see we have -3/5y plus 3 here. We multiplied by -5/3. So if I multiply by -5/3 this term, which is -3/5y plus 3, what do I get? I actually get y minus 5, 3 and 3 cancel, -5. So that is what we get. And what do we have here? We have y minus 11. So if you link these two, what is the vertical translation? Well, the vertical translation is -11 minus of -5, which is equal to -6. So here we get -6. Is that clear to you? That is how we could actually relate the mapping of the two functions. Clear? Perfect? So that is our answer. So in our case, the question was, using mapping rules, describe how this graph can be transformed into that graph. Now you have to describe. So horizontally, it is getting stretched by a factor of 2/3, right? Because you're getting multiplying it, right? So first part is horizontally stretched by a factor of 2 over 3, right? And then translate left because this is minus, right? We should write vertical first. Reflection on, this is vertical, x-axis. Then vertically stretched, I'm writing in short form, by factor of 5 over 3, and then we'll write translations. So it is minus, means we can write 11 over 3 left and 6 down. So that becomes the transformations. So that is how the function f of x will be transformed to yield g of x. Does make sense to you? So I hope that clearly explains how you could map and then write the transformations. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.